Hi, this is Mark Flair. In this video, I'm going to show you how to enjoy this calculus question, and it's read as follows. Determine the gradient of the curve x is equal to 2 root of t squared plus 3 at the point where t is equal to 1. So this question wants us to calculate or to determine the gradient of this curve at this point. So remember that you have been given a curve which is x is equal to 2 root of t squared plus 3. So this is our curve, the equation of the curve. So the first thing that we need to do is we need to find the gradient function. We need to find the gradient function. In short, for us to find the gradient function, we need to find the dx over dt. We need to find dx over dt. So for us to enjoy this one, we'll say, since we have x is equal to 2 root of t squared plus 3, we'll say let u be what is inside the root. So let u be t squared plus 3. Okay? If we let u to be t squared plus 3, let's find out what du over dt is. So du over dt, using the very simple derivative rule, this will be 2t. And then the derivative of 3 is what? 0. So this 2t is coming from the derivative of t squared. So since the derivative of 3 is 0, there's no need of writing a 0 here. So we know the value of du over dt. Now remember that we have let u to be this. So this simply means that x is equal to 2 the root of u, like that. Okay? So if x is equal to the root of u, we can also write it as 2, okay, u raised to the 2 power half, like that. So from here we can find the dx over du. So dx over du, we are going to take this half, this side, and then we multiply by 2. So the answer will give us a 1. So mean that we're going to have u raised to the power negative half, because we are going to subtract negative 1. So this is actually the principle of differentiation. Okay. So mean that dx over du is equal to u raised to the power negative half, which is also the same as 1 over root of u. Since we know that the square root is the same as what? Half. Okay. So from here, we can conclude that dx over du is equal to 1 over root of u, like that. So now, what we have found so far, we have calculated du over dt. We have also enjoyed dx over du. But what are we looking for? We are looking for dx over dt. So to find dx over dt, so I'll write dx over dt is equal to, we are going to use, it's more like a chain rule concept. So we are going to state that dx over dt is equal to dx over du times du over dt, like that. Where dx over du is 1 over root u times du over dt. Du over dt, this is our answer, which is 2t. Okay? Now remember that this is not our final answer, because there is a function of u. The initial equation is not having u. But we said that let u what? Let u be t squared plus 3. So wherever there is u, we'll put this. So mean that dx over dt is equal to 1 over root of, what is u? It's t squared plus 3 times 2t. So this is the function of dx over dt. If you want, you can simplify it by saying 1 times 2t is 2t over the root of t squared plus 3, like that. So therefore, dx over dt is equal to 2t over the root of t squared plus 3. But is this our answer? No, this is not the answer. This is the gradient function at a certain point. But this question is saying we need to determine the gradient where t is equal to 1. So I'm going to erase this. I'm going to erase this part. Okay? So now, since we know that the gradient function is dx over dt is equal to 2t over t squared plus 3, to find the gradient where t is equal to 1, this simply means that wherever there is t, we substitute what? 1. Very simple substitution there to enjoy. Okay, so mean that we're going to have 2 times 1 over, so t, we're going to have 1 squared plus 3. So this is equal to 2 over the root of, okay, 1 squared is 1 plus 3 is 4, which is equal to 2 over 2, which is equal to 1. Okay? So this simply means that we can say, therefore, the gradient, if you want, you can write as a full word, or if you want, you can say m, because m stands for gradient. So gradient is equal to 1. So this is our answer. Very simple of enjoying this type of question. Thank you very much for enjoying this question with me.
Mr. Matslayer, you are the one who help people how to solve it. Mr. Matslayer, you are the one who help people how to solve it. Mr. Matslayer, Mr. Matslayer, Mr. Matslayer, oh, Mr. Matslayer, Mr. Matslayer, Mr. Matslayer.